Okay, so in this lesson, we're going to go over the derivative of the natural log function. Okay, so try to get through this relatively quickly here. By all means, you could always pause and rewind and watch again. So for y equals ln of x, okay, our natural log function, keep in mind, natural log function, this is a logarithm with base e, okay, that y prime is equal to 1 over x. Okay, so we have this relationship here that if y is equal to ln of x, then the derivative of y prime is equal to 1 over x. Okay, so that's the first little log kind of rule we have. Okay, and that's all, that's fine. It's a specific function, clearly ln of x. More generally, all right, we want to think about given u is equal to some function of x. So u is f of x, some function of x. If y equals ln of u, okay, then that means y prime is going to be equal to, we could just write u prime over u, okay? Sometimes we'll say, the derivative of the stuff over the stuff, okay? Another way we might see this, we could have it as 1 over u times u prime. We could have as 1 over u times du dx, okay? But they all mean the same thing. All right, so that's kind of our more generalized rule in terms of the derivative of the natural log. All right, so ln of the stuff, ln of the, in this case, u is the stuff. Right, what's the derivative of ln of the stuff? It's the derivative of the stuff over the stuff. Okay, so we could kind of say it in simpleton terms that way, layman's terms. So over here, let's go through a couple examples. So here we have ln of what? ln of u, right? So u is my 4x. That's my stuff. So what is the derivative of ln of 4x? Well, y prime is then just going to be equal to the derivative of the stuff, which is 4 over the stuff, 4x. Okay, that's it. Done. We could simplify, but there's our derivative of that for that one. Number 2, right? What's y prime? Well, y prime is equal to ln of, that's my stuff. So what's the derivative of the stuff with respect to x? We're taking the derivative of these with respect to x. So the derivative of x squared minus 3, 2x over the stuff, x squared minus 3. Done. There's that one. Okay. We'll go over here to number 3, right? Y prime. Again, the derivative of the stuff right there. So what's the derivative of that? 6x minus 5, the derivative of the stuff over the stuff, right? That's it, right? Because all this stuff right here is my u, okay? That's my function of x. There's number 3. And then number 4, y prime. Well, keep in mind here we have another way to think about this is that y is equal to ln of x to the 1/2. Okay, so that's my stuff. Okay, so here we have the derivative of the stuff would be 1/2 x to the negative 1/2 over x to the 1/2. Okay, there we have that. And we could simplify that from there, right? Y prime is then equal to 1 over 2, and then we have the square root of x times the square root of x. This is going to move down, becomes x to 1/2, so we get 1 over 2x. Nice and neat and simplified. So that's all there is to taking those derivatives. Pretty darn simple. The ln part, not a lot to worry about with that. There's nothing to do with that. Okay, it's really a matter of being able to take derivatives of polynomial functions, right? Maybe some trig functions, radical function here. Okay, that's all you got. So let's go over here, look at a couple more. So now here, what do we have? Well, now we start to combine rules. Okay, here we have y equals the square root of ln of x. So now we want to think to rewrite this, that we have ln of x in parentheses raised to the 1/2. So in this one, finding the derivative requires us first really to do the chain rule. So we have y prime is going to be equal to what? 1/2. Keep everything inside the same. To the negative 1/2, drop the power, then times the derivative of this stuff, right? What's the derivative of ln of x? Well, now we got to think of, well, forget everything up till now. This is my new problem, taking the derivative of ln of something. So what's the derivative of the stuff, the x? 1 over the stuff x. And there's that one. Okay. Number 10, We have cosine of what? Cosine. We're thinking y equals cosine of u, something, right? Y equals cosine of u. So if that's the case, then what do we have is y prime. Up here, y prime would be what? The derivative of cosine negative sine of u times u prime. All right. Now the u in this case is right there. That's my u. Okay. So we can think kind of generally, and that may help us sometimes with what to do when we have specific functions here. So what's y prime for number 10? Y prime would be, well, I have outside function, inside function. So we have a chain rule going on. The derivative of cosine, negative sine, the derivative of the outside function, keep the inside function the same, ln of x, then times the derivative of the inside function here, ln of x, which would be just 1 over x. Okay, there's that one. This one, ln of u. So now we have the outside function is ln, and then we have the inside function u. So what's the derivative of ln of u, where u is equal to cosine of x? Right, the derivative of ln of u is u prime over u. So what's y prime here going to be? Well, what's the derivative of cosine of x? U prime. The derivative of cosine, negative sine of x over u, the stuff, cosine of x. Okay, and we might see this one as negative tangent of x, right? Cosine, sine over cosine. Right, but in either case, those are, right, two different ways you might see something like that. And now we have over here, sometimes this one gets confusing here. You have ln of x, ln of x, but this is my u. So you kind of can forget, but say, what's the derivative of ln of u, right? So up here, this is not something we maybe want to get used to, because later on down the road, we're going to be doing this little substitution. And so, all right, well, what if I identified the u, kind of, and I wrote y equals ln of u? Then what would y prime be? U prime over u, right? And now I just got to go say, all right, well, u prime. Well, up here's u. So I can find the derivative of this function, u. What would u prime equal? Well, u prime would then be equal to the derivative of ln of x, which is 1 over x. So there I identified u prime, and then u as well, just ln of x. So what's that mean y prime is going to be? Well, y prime would be equal to u prime, which is 1 over x, over u, which is ln of x. All right. So we can do that little substitution. Okay, you can also think about what I said. What's the derivative of ln of the stuff? This is my stuff. What's the derivative of ln of the stuff? What's the derivative of that stuff? Which is, right, there's the derivative of that stuff over that stuff. Okay, there's a couple ways you can think about that one. So we've got ln of the ln of x, that the derivative is 1 over x over x ln of x. Well, you know, one other option just in terms of rewriting would be 1 over x times ln of x. Okay, something like that. That's kind of just simplified, so we don't have that complex fraction. Okay, let's go over here. Now, this is just review the log rules from pre-calc. When you have, this is called your argument of the log function a times b. And when you have multiplication, we get separated this into the sum of the two logarithms of those individual factors. ln of a times b is ln of a plus ln of b. With division, right, we subtract. Then when your argument's raised to the power, we can pull that exponent out front. Right there it is, okay? So that's just, in there you could look at that. That's the review. Now, 13. For 13, I'll do it the long way. And the long way would be to say ln of u, okay? So the long way would be to say, well, let's take the derivative of the stuff over the stuff. Well, in that case, y prime is going to be equal to the stuff. Well, now I got to do a product rule. It's x times sine of x. So if I say, all right, well, y prime is going to be u prime, this derivative of the stuff over the stuff. Well, now I got to take the derivative of this stuff right here, which is a product. I got to do a product rule. The derivative of x, 1 times sine of x plus x times the derivative of sine cosine of x. So there's my u prime over x times sine of x. Okay, and for that one, it's not too bad. Okay, there's my y prime. That is correct. Sine of x plus x cosine of x over x times sine of x. The other option is, though, to use these log properties to rewrite first ln of x times sine of x, in which case I'd have ln of x times sine of x is equivalent to ln of x plus ln of sine of x. So that's just rewriting y. I didn't take the derivative yet. Okay. And now when I rewrite y, this derivative becomes much simpler to do. I have y prime is, right, the derivative of ln of x, which is 1 over x, plus the derivative of ln of sine of x is the derivative of sine, right, cosine, which is then over the stuff sine. Okay. So, and these two are equivalent. Okay. If we separate this fraction, you would get this. Okay, and then for this one, I don't know that's any easier. Really. It's a little bit of rewriting, then the derivative is a little simpler. You don't have to do the product rule. But now when you get over to something like this one, okay, and you have here that you have ln of what? You really have x squared plus 2x raised to the 1/2. Now when I take this derivative, I got to do a chain rule, okay? Whereas rewriting this first, right, with this 1/2 out front, 1/2 times ln of x squared plus 2x, okay? If I leave this one as is, I got to do this chain rule. It's going to be kind of messy looking in the end. Here, rewriting it first now becomes pretty darn simple. What's the derivative ln of this stuff, right? Well, y prime is going to be 1/2 times the derivative of this stuff, which is 2x plus 2 over the stuff x squared plus 2x, and you're done. Okay, so that little rewriting step makes this much simpler to do. Okay, and depending how complicated this gets, it could even get easier by rewriting. Okay, so that's the idea there, using these properties to rewrite. Here we'll look at another one, two more. To think about this one, if I did this as ln of u, I got to do this quotient rule first. And then I'm going to have a complex fraction, right? But rewriting first, rewriting this becomes what? Ln of my numerator minus ln of my denominator, right? And now taking this derivative, wow, look how easy this is here. Y prime is equal to the derivative of x squared over minus the derivative of this stuff over this stuff. And you're done. Just a quick rewriting step and then taking the derivatives. Clearly we can simplify. And this one over here, this would be really messy. We'd have to do a chain rule, and then we have a quotient rule to take the derivative of this stuff. And then we got to put it over all this stuff. First, if I think of all this as raised to 1/2 power, I'm going to have 1/2 times, I'm going to write this in two steps, ln of x squared minus 1 over x squared plus 1, which is then equal to 1/2 times ln of x squared minus 1 minus ln of x squared plus 1. So this quick rewriting step using the properties of logarithms, now what's y prime? Well, y prime's ln of the stuff. So what's the derivative of x squared minus 1? 2x over x squared minus 1 minus 2x over x squared plus 1. And you are done. All right. So that's using the properties of logarithms to expand out your logarithm first before taking the derivative. Okay, makes it much simpler. So that's the way you should do it. Okay, it would be much messier doing this the long way. All right, I'm not going to waste time right now doing that. Right, but if you looked at this and just did it as is, the derivative as is, it'd be messy. It would be a little complicated. There's a bigger chance that you're actually going to mess something up, I think. Over here, now we start to combine various things. Okay, I want to find the derivative for here. What's y prime? Right? What's y prime equal? So what do? Take the derivative on the left. Take the derivative on the right. So now we're combining what? Derivatives of logarithms, and then we're going to have elements of implicit differentiation. So what's the derivative of x squared with respect to x? 2x. Minus, what's this derivative? ln of y with respect to x. Variables are different. So what's the derivative of the stuff, y with respect to x? That's going to be y prime, derivative of the stuff over the stuff, y, over y. Plus, what do we got here? The derivative of y squared with respect to x. So that's going to be 2y times derivative of y with respect to x, prime notation, y prime equals, over here, 0. And now I want to solve this for y prime. What I would suggest is let's multiply both sides by y to now make this 2xy minus 3y prime plus 2y squared y prime. All right. And then what? Solve for y prime. Okay, move the 2xy over, factor out the y prime, divide by what's left. So that would imply that y prime is equal to negative 2xy divided by, then when I factor out the y prime, what's left? Negative 3 plus 2y squared. Okay, so there we have a logarithm. We have implicit differentiation going on, so we can find some of those processes and ideas and concepts there. So there's find the derivative of that implicitly defined function that includes a logarithm. Okay. And then for now under here, we're going to find an equation of a tangent line. All right. And keep in mind, what do you need to find the equation of a line? You need a point and the slope. Here's the point. 1 comma 4 is the point. So I need the slope. But what's slope for us? Slope for us is derivatives. So I got to find the derivative of this. So what's y prime? Derivative of 4x squared minus the derivative of ln of the stuff, which would be 4x over 2x squared minus 1. Now I got to find the slope, y prime, in this case, just at the x coordinate 1, because my derivative is in terms of just x. So y prime of 1 would be 8 minus 4 over 2 times 1 minus 1, 1, for a grand total of 4. So there's my slope. Right, this is my slope. And I have my point. So in point slope form, y minus y1 equals m times x minus x1. Okay. And other than if there is an actual reason to put it in slope-intercept form, you do not need to do that. You can leave it in point-slope form there. And if need be, you could solve for y in terms of x and get it in slope-intercept form. So that takes care of the natural log, derivatives of the natural log. We have some properties in there we can use. Chain rule, we got implicit differentiation. You know, this kind of thing, find the equation of a tangent line to a function. All right, as these functions changes, the process is the same. You need a point and a slope. You're going to need the derivative. So whether this is a natural log function, it's a trig function, whether it's an exponential function, a polynomial function, all right, process is essentially the same. Make sure you look through this, write down notes, pay attention to all the little nuance of some of these problems and what you have to do. If there's any questions, make sure you let me know, reach out, and we'll get your questions answered.